Hi guys. So some weeks ago I did order this inclinometer. It's basically a spirit level you place somewhere to see how level something is, as the name would suggest. This was like a special offer and it cost like 5 euros. Normally they are like 10 euros. And I just opened it up. I did not need it. I just wanted to play around with it. And it's basically you place it and it will show the values. The display itself is quite nice. It's very good readable. And so far it's only possible to place it at the right side up to use it. And I looked inside of it, tore it down, saw that it has only one chip in the middle, and there's basically no like acceleration sensor extra. So it was quite clear that the chip in the middle, the main chip, is something custom. Also because it was quite thick and has some naming which were unnoticed. So I took down some sulfuric acid and extracted the dye out of it and just found out what is inside of this chip. Like it's two dyes. One is the acceleration sensor and the other one is the microcontroller. And turns out it is, as usual, an 8051 SoC microcontroller, and which has even like 32 kilobyte of flash, which is reprogrammable. And there are these like two wire debug header plus ground and VCC, which I looked into beforehand before unmounting the chip, but there were no activities. After finding out which microcontroller this really is, it also shows that it has like this OCD debugger interface and it is 2-wire, but it's something custom and special. Luckily, one guy played around with it like 5 years ago, more or less, and made a custom flasher or debugger for this specific interface. And since back then only one of these devices was available, I wanted to just check it further out and did order another one, as you can see here now. So in the next few days I will just take a look inside and see if I can extract maybe the firmware and just figure out what it's doing. And I will share it with you in a future time, whenever this is. But this is just the story to it. And the interesting part is maybe in this video more that I did not only order this one, but like, let's get them all here. Overall, I found 5 new versions of them. Also all around the 5 euro marks. I think only this one was like 14 euro because it claims to also has Bluetooth. As you can see here, it's a wireless inclinometer. And we now just want to look into each of them just to see if it's maybe like all built the same, all with its same chip, or if they are different from device to device and it's like everyone makes their own product, even while looking like basically the same and having exactly the same functions. Let's just start at the left side, and we will not do this one, of course, because it's the same as this. We can just start opening up this one and take a look inside. Or let's also turn it on beforehand just to see how it behaves. So far, most of the battery compartments are screwed close. I'm not so sure why this is, but it seems to be like always the case. And also there is like this Parkside inclinometer, which also looks basically the same. And most likely is like from such a company who makes these cheap ones and just resold under Parkside name. And yeah, so yeah, it's pretty similar to the first one from the function wise. It has this error if you place it somewhere else except for the right side up. So let's open it up completely and take a look inside. So far on all I have seen, the display is just a segment display, so nowhere is a matrix display, which is, I mean, better to be more readable, but it's a bit annoying because any custom firmware you may want to put on them is like also just segments that are possible to display. And yeah, let's zoom into this one. This already looks pretty different. Let's see if we can get a bit more light on it. Like so. And yeah, so inside of it, what can we see? We have like the LED for the backlight. We have the battery connector and some transistor or MOSFET for the power up. We have in the middle the main SoC, I suspect, an acceleration sensor, and here at the top is a display driver. The top one is a YL1621 and the microcontroller is a CMS79F5139. When the acceleration sensor is pretty much unreadable. There is something written on it, but maybe you can see it better. Or it's not helping to read it. It will be connected via I2C because we have two resistors of 4.7 kilo ohm. So this is a usual pull-up resistor for I2C. And I also suspect this microcontroller to be 8051 core because of the 51 in the name. Mostly these LCD drivers are connected via SPI, and I suspect it here as well. It's like just the normal method. Let's continue with just the next one here and also turn it on before. I will just go through all of them and just check them out. Okay, it's even just one battery. That's different to the other ones. And yeah, as you can see, the display shows not just R, but also the O, so this is different. But otherwise, yeah, it also works basically the same. Hold on and off. And okay, seems to be needed to hold it a lot. What is else here? Percent, millimeter. Okay, so this one definitely has a few more features than the very first one here. There was no like millimeter function or such. So this might be a little more interesting or a little more feature-wise in software. Let's take a look inside. Very big screws in comparison to the other ones. It looks a bit more rugged. Okay, and the case open up in two places. Okay, that's also quite different. We have like one microcontroller which has to include the LCD driver. As you can see, basically the segments to the LCD go directly from the main chip. You have the acceleration sensor here, but it's unclear if it's an analog one maybe. You have like, yeah, the voltage regulator again, or this could be the driver for the backlight. Ah, okay, no, it's here. So this will be the voltage step up converter most likely. Here we will have the display LED MOSFET to turn on the backlight. And this is most likely MOSFET to turn on the acceleration sensor. Otherwise we have like a debug header with UART. Could be interesting if it's just printing something out. I will look into that later. And yeah. Also to go back to the other one, here's of course also this debug header, but could be anything at this moment. It will be this, yeah, CMS debug port, most likely. So let's use the next one. Oh, take a look in the next one. This is a bit different. It also has the spirit level on top. So it's basically like a 2-in-1, but it's the same function in between. The display one will be a bit more detailed. Okay, so here we do not even have screws to put on the battery cap. And yeah, but from the elsewise it's very similar again. Like zero and backlight. Not more functions than that. Let's also take a look inside. Okay, so let's zoom in a bit. This one looks very similar to the first one we looked in today. Let's compare it. So you have basically the same microcontroller in the middle, the display driver, but unnamed on this one. It's very likely the same in between, and an I2C acceleration sensor again, because we have here this 4.7 kilo ohm resistors, and otherwise, yeah, the name of the acceleration sensor looks also the same. Same number of pins for the debug header, and yeah, also like the voltage side looks a bit different actually. Here we have this inductor, which is missing here, but otherwise this one looks very similar. Maybe there's some naming, but no, we have like here this JD5, but nothing on the other one. Okay, so these two are quite similar. Interesting. Let's go to the next one. It's basically also looking the same again. This one has no screws on the back, and it's most likely, as with the very first one I looked in, that under this screen protector or front, the screws are hidden. I think it's possible to see it here. Yeah. So you have like this front you can pull away with minimal damage, and yeah, it's working that way. Let's also turn it on. Oh, that display looks very bad. So it's basically unreadable really, only from that angle. Ooh, that's not very nice. Okay, but otherwise, I mean, I can read it barely, but really not nice. So this is not good as a first review. And yeah, so let's open it up, just because we are at it anyway. Yeah, okay, so we have like here the screws hidden. You can be more careful while doing it to not damage it too much, but it's already like breaking in many parts. That's not a good target for any tinkering, I would definitely say. Okay, so yeah, that's, I mean, with that backlight it's not usable at all anyway. But let's take a look inside. I mean, in theory you could even just leave it away afterwards. It's not looking too bad actually, but with that backlight, yeah, it's just not worth it to put any effort into it other than knowing what's inside. If I'm ever able to get the screws out fully. Yeah, that looks good. And now we should be able to just pop it away. Okay, it's the back side. And okay, that looks interesting already. I'm seeing the SWD interface. So this is very likely ARM based. Just as a very first result. For once, we will have most likely the same display driver as in the first and the fourth one. We have even connectors, so this seems to be a bit more pricey overall. We have voltage converters, like MOSFETs for the driver. We have even like debouncing capacitors for each button. An acceleration sensor here in the middle, which will also most likely be a 3-axis one. And then we have the microcontroller itself. Let's zoom a bit more in. Oh, let's do it manually. Ah yeah, it's ARM based. HK32F030 MF4P6. So that's definitely a nice target for a custom firmware, but with this backlight, it's not fun to use it in the end. Let's just look at it again. Yeah, it's just barely visible. Not sure if it can be increased somehow, but that's not fun. Yeah, also to mention it, on so far everyone I tested, if you hold the right button and turn it on, you get in this calibration mode and you have to place it in different orientations. But yeah, just to have talked about it. So yeah, interesting from the microcontroller wise. I will definitely try to read out the firmware just to see what it does and how good it's reversible. And you also have this second debug header here, which is most likely then a UART port. Maybe it will also output stuff like the orientation, and that way you could do anything with it. Yeah, just some thoughts to it. Okay, and now the last one, let's zoom out again, is the wireless one. I did not took a look inside of it or have used the wireless function. Basically it's like half the size of all the other ones, barely. But otherwise it just works the same. I guess there are more options. Now the Bluetooth is enabled. I will take a look into that later. For now it's just about the opening, and I would maybe even suspect this to not have any screws at all. I will just try to pry it open like this and zoom into that. Yeah, but it's too hard to pull it out. So there will be some screws. Let's start at this back label. Ah, yeah. So these are super tiny screws behind it, but it's good that's on the back, so the front does not get damaged by removing it, like so. Yeah, these are tiny screws. Let's get out some better fitting screwdriver with the smallest possible bit. That will work out. It's also worth to mention that this Bluetooth one is the same company name as the very first one, this Shahe, or how you pronounce it. So either there's one extra module just for BLE or one extra chip for BLE, and the main processor is like one of the usual ones, or everything is done by the BLE module. But yeah, as we can see already, we have this extra module here inside, which hints on it to be like just an added module. And normally it's like you can even order it without Bluetooth, and then this module is just missing. This one is of course also different because it has a LiPo battery and a USB-C connector where you can charge it. And yeah, let's maybe look up the naming of the Bluetooth module first. And there we can also already see some clock naming. Let's try to not destroy it too much. And what do we have here? Looks like dialog. It's like a DA, so it's also ARM based. DA14 something something. DA14580, something like that. So this is also ARM based and quite powerful, quite overpowered for its function, even with external flash on the back. And yeah, let's also unplug the battery and get out the main board as well. But then it's also, I would not call it uninteresting, but it's not as funny to reverse two chips and do something with it. Maybe it's just nice to have Bluetooth to really use it in some other application, like planning, or if you have some automated machine, you could use these values just as an interesting target for any tinkering. And yeah, that looks to be openable. And yeah, that's also, this chip here inside is the same one as is also in this other one where I extracted the die. I can tell this already. So it's this 8051 core with the internal acceleration sensor, like this MT831. So this will also again be this special debug header. And yeah, overall it's quite funny, as this external microcontroller is like X amount the power and usability of this internal one. But I guess because this software is already finished and is like already established and debugged, it's worth to just add a module externally on a UART connection. This this one kind of the most interesting one of them all, because you have like the LiPo battery, even if this is like 14 euros, even in the offer. And yeah, you could do the most with this one overall. Okay, that's quite interesting. And I hope you like this dismantling of different types of inclinometers. At least the way I liked it, as I love to just look inside of the stuff and see the difference, especially on these. It's like and not too much money wasted just for this. And yeah, okay. Have a great day.